You people learn about the basics part of the remote sensing and the basics part of some GIS. Okay, and just a little bit of away from that, we will discuss about today's class is about unmanned aerial vehicle. I will give you a broad view of unmanned aerial vehicle now in terms of what is the introduction and about what is the history of UAV in terms of the surveying, and again we are going for the various components of the UAV, and again we will go moving towards the various classifications of unmanned aerial vehicle. Then we will discuss a few applications about the civilians and other defense and water resource and other environmental and mining sector applications. Now this is about the broad the classification of the today's class, various categories of the UAV. Okay. Now we will start first one, that is about the introduction to the UAV. If we see the various technology developments, especially in the geomatics engineering. Now everybody knows about the geomatics? Little bit? Okay. Now otherwise I will give you a small picture, will give you an idea about if you broadly classify the geomatics engineering, there will be the four major themes. One is all about the remote sensing, how the various satellite images captured by keeping the various things into the consideration of spatial resolution, spectral resolution, radiometric resolution, and temporal resolution, and talking about the various satellites who can environmental monitoring satellites, geospatial satellites, and polar orbital satellites, and finally we are talking about the ground monitoring satellites who can give you the data in terms of the spatial, spectral, radiometric, and temporal resolution. And coming to the digital image, this is just like an introduction about the geometric, then we will talk more about the UAV and all those things. And coming to the digital image processing, what are the images we are getting? That image is having noise, and that image should be enhanced. Why? Because what are the information we can extract, that is not clear. We can extract that information in different formats. Another example, in the olden days, the photo is captured, there will be some red color on the eyes. Okay. Now one of the tools that is in Photoshop, otherwise Microsoft, if you simply click on that particular one, that red color eye is removed. But now we are having the more advanced techniques to remove and to change the beauty of the original raw image. Having the Corel software, Photoshop, Adobe Photoshop, there will be a lot of software things we can edit the photograph. And in mobile phone also, the iPhone and all those things, they are having the live image processing tools and the live photograph itself. In the similar way, once the satellite is captured the Earth surface, what are the images what we are getting? From that image, the final objective is we can extract the information. Maximum information we can extract it. For that extraction, the image should be clear. Okay. Now, due to the atmospheric conditions, due to the mechanical problems in the concerned sensor, otherwise concerned mechanical instruments in the satellite, there will be some noise, otherwise some obstacles in the satellite. We can remove such kind of errors by using some techniques. Okay, what we are calling as processing, image processing. Image means here we are talking about the satellite image. we are talking about geometrics. Okay? Processing, image processing, that image should be in a digital format. Earlier we are having analog satellite images. It means paper kind of maps are there, separate with NRS. Nowadays we are having all the satellite images which are available in digital archive. Now the digital, the image which is processed for execute the image in a GIS environment, otherwise extract better extraction of information from the satellite image. Now coming to the third one, that is about the GIS. Now with the help of this satellite images, with the help of the survey records, with the help of the attribute table, and with the about other sources of data, we may prepare the spatial information system. Now whatever the Google Maps, the information you people are required is the restaurant near me. You are typing simply the restaurant near me. How a satellite is understanding where is the restaurant? It requires two things. One is your location, and next one is the information, the spatial and non-spatial information around that particular location. It means that the information should be known, it should be created. That created information we are calling as a in a platform called GIS. That is called as a system which is created on the basis of certain information for the geological features. For geological features, the information kept in a particular system, prepared in a particular system, completely we are calling it a geographical information system. We created for a geographical features what we are observed on the Earth surface. I think we will discuss in rest of the classes about what is GIS, what is remote sensing, with digital image processing and all this thing. And next one is about the GPS and GNSS. It is talked about the position on the ground surface. We are having the multiple ground-based techniques. Total station, robotic total stations are there, and other digital, what we can say, digital levels are there, auto levels are there. Take it. Laser scanners are there. There are some ground-based instruments are there to determine the position on the Earth surface in terms of x, y, z. Now, instead of the terrestrial instruments, a space-based satellites which are kept in a certain constellation. On the basis of those satellites, we determine our position on the Earth surface in terms of the x, y, z. Okay? Now, a certain satellites which are kept it in a space, in a certain orbit. Now, this is one orbit, this is another orbit, this is another orbit, this is another orbit. Like this, in a certain orbit, we are calling as a constellation. In a constellation, some satellites which are kept by the various countries. Okay? Now, on the basis of those satellites, on the basis of their positions, the position on the ground, the object position on the ground should be determined. Okay? By certain communications with the GPS. We are calling this concept, we are calling as a GPS. It means the what we can say, by using the Navistar, if you use the constellation of the Navistar, we are calling it the GPS. Other than the Navistar, there will be other constellations like Villuri. Other constellations are there. If you can use those things, we are using the global navigation satellite system, GNSS. Okay? Now this is the, and other than this, photogrammetry is also there. Okay? These all the combinations we are calling as over the period of advancement. The techniques are coming into the picture, we are adapting those pictures, and finally we are moving for the mapping and surveying. This, the combination of these all topics we are calling as a geometrics engineering. Okay? Now we will move ahead about, now in the advancement of the geometrics, what happened in the ground-based robotic total stations, and other techniques like LiDAR and the GPS kind of surveys, and another kind of advancement in terms of the mapping that we are calling as a UAV, that is Unmanned Aerial Vehicle. Okay. Now what is the purpose of Unmanned Aerial Vehicle? And in terms of the definition of we talk about Unmanned Aerial Vehicle is an aerodynamic force which can uplift a vehicle in terms of some mechanical devices and cover the geographical features for a larger area in a short period of time and produce the various maps and digital elevation models for modeling in terms of the flood modeling, in terms of the topographical mapping, in terms of the surveillance, in terms of the various other road networks and all those things. Representation of the various road networks and other things. Okay. This is one way of defining the UAV. Okay. For in terms of the surveying point of view. If I will show you the now unmanned aerial vehicle, the mapping. Here I am talking about the mapping, also known as the drone mapping. General term, what we are circulated in our society, we are calling as the drone mapping, is the process where drone acquires with cameras, having cameras, LiDARs and other sensors, capture the data in a air and create the maps and 3D models and also geographical data sets. Whatever the data we are captured from the drone, from that particular data, we can make a 3D models and we can make a topographical mapping and we can make a geospatial data sets also. Already I said that what is the advantage of geospatial data sets. Okay. Now again, this technology is revolutionizing mapping and surveying by providing a high resolution and cost effective. Now while compared to the other existing, other previous techniques, now one of the technique what we are talking about, now let us example UAV, and another one is about the aerial photograph with respect to helicopter, and next one is about the satellite. This is also capture the photographs from the atmosphere. This is also capture the photograph, and this is also capture the photographs. Okay? Now let's talk about what is the advantage of these three. These three are surviving our purpose. Finally capturing the photographs. Now if you talk about the satellite, for launching the satellite and keep the satellite in certain orbit and again collect the data and again send that particular data to the concerned receivers on the ground, and we process that particular data and sell that data to the civilians or other military defense purposes. Okay. To launch and this particular process, the cost is little bit of higher while compared to these two. The cost is around 200 to 250 crores. Sometimes it will be 400 to 450 crores for launching and keep the satellite in a particular orbit. Now coming to the helicopter, otherwise aeroplane. Now once it is flying in the air, almost it will travel 1 hour, 2 hours, 3 hours, and it will completely capture the area and again it will land it. Now in the political campaigning, the candidates, they are acquiring that helicopter for rent. As of my information, per day the helicopter cost is around 5 lakhs to 10 lakhs. Now let us acquire the helicopter with a proper setup of, there will be certain helicopter with having a proper setup of the photogrammetry. Acquire, book that particular helicopter, you can fly whichever area you want to survey and it will capture all the photographs and it will come down. How much cost it is? Booking of helicopter is around 5 to 10 lakhs, and again pilot cost, let us take it is around 1 lakh, and other instrumental and maintenance cost, that is around 1 to 2 lakhs. Now within 10 to 20 lakhs we can get the information about the same area. We have to capture IIT ISM Dhanbad. For the satellite image, you have to count the whole process, na? Construction, build the satellite and again launch the satellite, keep it in orbit, finally it will give you the data. But the same capturing of IIT ISM Dhanbad, for this helicopter process. Again the same, pilots for booking, acquiring the pilot, and again run the pilot, run the aircraft, and do the survey for around 1 hour, 2 hours, and finally land it, and we can collect the data. Again, that is also, while compared to the satellite, the cost, in terms of the cost, it will be a little bit of lesser. That's why written as a medium. In terms of the cost. Now coming to the UAV. Now while comparing to the helicopter, the cost of the UAV is a little bit of low. Another example, this is 5 lakhs per day. The drone, the cost of the drone per day, the booking is around almost 50,000 to 60,000. Okay? And again, the trainee pilot, the cost is around 10,000 to 25,000 per day. Again, they are doing the same battery charging and everything. It is cost is around 1,500 to 2,000 per complete full battery charge. And they are also fly the drone, and they are collecting the data, and they are produce the data in terms of orthomosaic images. Now, while compared to the satellite images, around in terms of 200 to 252 crores, it is coming under 10 lakhs to 20 lakhs. Again, the UAV is coming under less than 1 lakh. Okay? For a particular area I am talking about. Okay? Now again, this is a little bit of advantage while compared to the satellite image and while compared to the aerial photography with respect to the fixed photogrammetry instruments in terms of the cost. Okay, now the people are adapted to this particular technology, and instead of the satellite images, it will give you in centimeter to the meter level of accuracy. Why? Because in a low altitude it can fly, and it will give you meter level of accuracy. It is, let us example, 10 meters, 1 meter to 10 meters it will give you, and it will give you again 1 meter to the 30 meters, it will give you the accuracy. The satellite image, the minimum accuracy what we are getting is almost 0.8 centimeters are also there, but certain Indian satellites, if we can talk about, it will give you from 80 centimeters to the almost list 5, it is around list 4 is around 5.8 meters. And again, if we go for the Landsat and all those things, it is going for a lower accuracy, that is 23.5 meters, and again the beginning. Okay? But the UAV which is giving, it is almost a centimeter. Why? Because the satellite which is captured at from a height of 700 kilometers altitude, 700 to 900 kilometers altitude. But this is capturing almost 100 to 200 meters, otherwise less than 1 kilometer. Obviously, it will give you a better accuracy. If I can capture the geographical features in an accurate manner, cost is also less, and even though it is producing a good accuracy. Now the people are taking the advantage for UAV, for a kind of surveying works and mapping. Okay? So this is one of the advantages why the people are adapted the new technology of UAV into the, especially into the geomatics. Okay? Now, if you go for the brief history, in 1958, the people are adopted the technology of aerial photographs in a hot air balloons to capture the geographical surface. Now, in 1958, the NADA, that is what we are calling as a Dhanbad, from using a hot air balloon over Paris, marking the beginning of the air balloon images. It means that he is sitting on the hot air balloons and capture the aerial photographs. Now initially he utilized in Paris. Now after that, especially in the Caterpillar, there is one kind of UAV which is launched in the World War. In 80s, kite photography, if you see the small camera, I don't know whether it is visible or not. If you see this is a small camera, it is visible?
Yes.
The small camera which is attached to the kite. Okay? Now that is used with other but using kites to capture the aerial images for mapping of landscapes. And in the World War I also, this kind of aerial photographs are captured and throw the bombs in a hot air balloons. They attach some bombs, okay, and initially they identify where is the opponent, and they attach certain kinds of bombs to the balloons, and they can fly, and the balloons are fly up to certain distance, and the balloon will be dropped in the opponent location. Okay. Now that concept what we are talking about the aerial photography. Okay. And next one is about in 1906, George, which is used a large kite system. If you see that one, the last photograph, George kite system to photograph a San Francisco after the earthquakes, providing aerial photographs value for surveying and disaster zones. Nowadays, if you observe the government officials, the senior authority of the government, they are moving in helicopters to after the flooding. Certain flood is there. After the flooding, the chief minister, otherwise some of the government officials, they are moving in a aircraft, and they are identifying how much area which is submerged and how much area that is completely damaged. Why? Because it is very difficult to move in such places manually, otherwise by walk, on road. Now this, if you see 1906, such kind of huge amount of aircrafts they are flying to identify the landscaping, otherwise earthquake zones. What we nowadays observe with helicopter mapping. Helicopters they are observing the submerged areas and all those. Now this is about the evolution process of the aerial photography mapping. What I said in the earlier, the aerial photography, which is a specific aircrafts which are having attached a complete camera and everything. The aircraft is moving and it will capture all the photographs. Once we got all the photographs, we can go for the mosaicing and go for the mapping. That is camera which is mounted to the helicopter, otherwise certain kinds of aeroplanes. Now in the process of the particular evolution, in that is in the 20th century, aerial photographs leading to the UAVs, unmanned aerial vehicles. Now in 1914 to 1918, the World War I, what I said, piloted aircrafts were widely used for aerial reconnaissance survey and mapping, highlighting the military needs. Here the reconnaissance survey means where is the opponent and where the vehicles are kept, where the offices are there, and what are the routes are there. Now a preliminary investigation about the opponent location. That we are calling as a reconnaissance, especially in case of war. Suppose in terms of the surveying, if we talk about the reconnaissance, where we can keep the control station. Now let us talk about this camera. Before setup, what is the reconnaissance? He can move around the classroom and he can identify one place where the maximum area is covered. Okay? Now he can initially move around the whole classroom and he identify at least one or two positions where he can identify the maximum classroom without any disturbance. Then there he kept his camera setup and finally go for the shooting. Initially for the surveying also, before going to the survey, we have to roam around the complete area where we can keep our stations and all those things. First of all, we have to choose those locations. Then we can fix the location and go for the surveying. In the similar way, especially in case of the wars, the reconnaissance should be where the opponent is there, how we can approach, what are the various ways to approach. That is the planning. Okay? Now for that particular purpose, in the period of 1940 to 1918, these aerial photographs are used. But there, only the problem is they are using the hot air balloons and all those things. The problem with the hot air balloons and all, this one is it will vary the altitude. Not in a single altitude we can. It means there is a disturbance in the images also. There is no much clarity on the images. Now again in the 1960s, the aerial targets and early drone prototype development by the British Royal Flying Corps was intended to both target practice and aerial photographs. It means instead to avoid such kind of variations, the targeted areas actually they captured. Instead of the complete area, we are going to certain areas where to stable capture of images are focused on. And again, for the period of time, the technology is coming into the picture. Earlier, only the hot air balloons are there. Now the technology, various sensors which are coming into the picture to scan the area, to capture the area in such a way with thermal cameras, hyperspectral cameras, RGB cameras, and flying wings, and the kind of material which are captured. All these things which are now in 2010 to 2024, the drone mapping became a mainstream with advanced photogrammetry techniques. With LiDAR, RGB, and multispectral imagery, thermal imagery, revolutionizing like industrial in terms of the agricultural, construction, and environmental monitoring and water resource monitoring also. It means from initial stage of hot air balloons to certain in a world war for a flying up to 120 seconds. Initial unmanned, in hot air balloons, the person is sitting in the belly. He captured. But what is the purpose of UAV? Unmanned aerial vehicle. No man should be there in the instrument. Now in the initial what we can say fly of unmanned aerial vehicle, that flight only at 120 seconds. Okay. Now over the period of time, the technology, the kind of material, the kind of batteries are coming into the picture, the kind of sensors which are coming into the picture to fly from 20 minutes to the almost 1 hour to capture the whole area. If you see the initiative of UAV, unmanned aerial vehicle, that is from a looks like a honeybee. If you see the honeybee, the 4 legs, okay, it can move in such directions. And if you see the eyes, front end eyes, and there is flying wings, okay, and there will be some head which is in forward direction. Okay. The similar kind of structure they are taking as a reference to for making of UAV. Okay. It means again the 4 legs for standing and flying wings for the upliftment. What is the advantage of honeybee? Whenever they record, vertical flight can be taken off, and angular flying also can be taken. Whenever required, it can immediately go for the landing. And there is a vision with eyes, front and eyes. With the same kind of structure, the UAV they are prepared. Now this will be looking called as the module of UAV. Just in terms of the honeybee, I am explaining about. Now these are called the 4 legs for landing. These are called flying wings for upliftment, and this is the camera for observation. And this will be again, there will be a first viewer camera that will be on the top of this particular UAV, which will give you which area you want to capture. The controller can see the camera, and this is the area you want to capture. We are calling as a first person camera. Okay. Now we will discuss what is the various parts, what are the various parts, and what is the functioning of the particular parts and all this. The first one we are talking about the propellers. In terms we are calling as a fans. If non-technical term if I can use, that we are calling as a fans. If you see, these are called propellers. So 1, 2, 3, 4. These 4 propellers which helps us to lift the UAV in upward direction and moving forward direction, moving backward direction. Okay. Now the next one is about the motor, which helps us to run the propellers. The motor which helps us to run the motors, and another one is about ESC, electronic speed controller, ESC. The electronic speed controller which controls the movement of the fan, like speed and medium and low kind of movement of propeller is required, especially in the atmosphere. Why? Because in the atmosphere the weather is unpredictable. Sometimes the wind is too high, sometimes the wind is low, sometimes the wind is medium. According to that only we can sustain in the atmosphere. If the wind is too high in the opposite direction, the propellers should maintain in a stable condition in the atmosphere with reaction of the opposite air. Okay? In the similar way, the motor is also working as per the proportion of the atmospheric conditions. It should be controlled by the ESS, electronic speed controllers. And next one, if you see, there is a camera mount. We are calling as a camera gambler. Now, camera gambler is about how much payload you want to keep and how you are mounting your sensor, RGB sensor, thermal sensor, hyperspectral sensor, cameras and everything, how it is mounted and how it is rotated. The camera is not only in the one direction, it should be in a multiple directions. Now that we are calling as a camera mount. And next one we are talking about the lithium battery, which produce the power supply to the complete mount and for the working of the ESC and the motor and what we can say power supply to the various sensors. And again receiver. The receiver which communicate to the remote control ground-based remote control signals to the concerned UAV in the atmosphere. It will communicate. Someone should be there to communicate my signal to the concerned UAV. Now, if you see the complete what we can say UAV, various components of the UAV, some things which are input, some things we are calling as an output, and some things we are calling as a static. Those static we are calling as a this stand. We are calling as a landing gear. What is a landing gear? It should be properly landed on the ground. Okay. Now in this case there will be 4 legs are there, and some cases it will be rectangular kind of handles are there. It is depends upon from various what we can say the UAVs. Okay. Now if you see the input data that is represented in the particular figure in a green color. Now here the input data will be the controller. From the remote control we can provide the signal like moving forward, moving backward, moving left and moving right and all those things. And next one is about the first video camera. First video camera means that camera will give you the information in a controller board which area actually it is captured, to be captured. Okay? Now that is the video camera in a control board. And next one about we can view such kind of information in a Google lenses also, virtual lenses also, and with respect to the camera. And coming to the energy, that energy will be provided through the lithium ion battery. किस को supply करेगा? It will be supplied to the motor controller, and I skipped this one, that is called flight controller. Flight controller is the brain. Is the major brain part of the UAV. It controls the stability of the UAV in terms of receiving the signal, position of the XYZ should be coming from the GPS signal and provided to the camera in which direction it should be moving, and giving signals to the propeller and which speed, whether it should be moving forward, backward, upward, downward, whatever the signal, like our brain is giving to us. Okay? It is a complete brain to the UAV, and the battery supply should be given to the motor controllers also, and again the speed controllers also, where it can, like what we are calling as a food to our brain. Okay? Energy to our brain. And similarly the signals, here the signals, one signal we are receiving from the GPS, like what we are having in our mobile phone. We are receiving the GPS signals like the GPS module which is kept in the master controller, flight controller, and it will receive the signal. Now what is the need of the GPS signal? Especially in case of the radar kind of scannings, we require X, Y, Z of the particular position on the ground. For this purpose, we require the GPS module. the signal will be directly taken from the satellite system. That will be inbuilt in the controller. It will be forwarded to the camera and all those things. And other than this, is there anything? And receiver that will communicate the signal from the particular remote control to the, what we can say, the major flight control board, and the camera orientation and all those things can be through this particular receiver only. Now here I am uploading in the remote control, move left side, move right side, that signal is received by the receiver and it will communicate to the concerned mounted equipment. And again, these are the cameras, these are the gamblers, and the power supply that should be completely given to the lithium ion batteries. Okay? Now here these we are calling as the components of the UAV. These are the explanations what I explained from the last 5 minutes. If you see one thing, the first one is called as a airframe. Now that is the structure we are calling as this one. I shown you. Sometimes it is a legs and sometimes it is like a rectangular and sometimes it is called as a A-shaped things are there. It is from instrument to UAV to the UAV. Those are varied. On the basis of the structure, on the basis of the material, those are classified. Next one is about the power system. Now we are having the lithium polymer and lithium ion batteries are there, and the capacity, the payload capacity is increasing. Higher capacity of the lithium ion battery and higher payload. It should be a higher payload to the concerned UAV. And the flight controller, it is a brain. Flight controller is a brain that processes the sensor inputs and the controls the motor to maintain the stability and execute the flight paths. It means if I given a control, proper control to the UAV, you move in this direction and again you move in this direction and again you move in this direction to cover the whole area. Now the flight controller take instructions of mine, otherwise in autonomous mode it will do like this. It will cover like this. Maybe in some other person, some other trainer can give like it will move, it will capture like this also. As per the instructions given to the flight controller, it will take the instructions, it will follow. And these are the global navigation system what I discussed and the GPS module which helps us for the signal and XYZ to the concerned UAVs data collection. And next one is about the radio transmitter and receiver. The advantage of this one is it will receive the signal from the controller and transmit it to the UAV. And next one is payload. Here the payload will be, as I said, there will be a small cameras, small sensors, higher sensor, bigger kind of thermal and lidar sensors. Now the payload is talking about what is the weight you are mounted to the UAV. Okay, now as per that also the type of UAV changes. The classification of the UAV changes as per the weightage also. Now here if you see in the payload, the certain cameras, normal RGB sensor cameras are there, infrared cameras are there, multispectral cameras are there, lidar sensors, thermal sensors and delivery mechanism. Sometimes the UAV can be utilized for transportations of medicines, especially in case of disaster areas and all such areas, the medicines can be supplied. In such cases, the payload should be a little bit of higher. Okay, now that is called in terms of medicine area, how the UAVs are used. And next one is about the propeller, which is moving for the upliftment of the UAV and the forward direction, push or pull. That is completely depend upon the movement of the propellers. The orientation of the propeller will guide the UAV moving in forward direction or backward direction. Okay? And that kind of materials which are used for the propeller design, that is also cost dependent on the type of UAV. Okay? And next one is electrical and control system, ESC, electrical field control systems, which helps us to control the, what we can say, the motor speed from low to the medium to the higher range. Sometimes to sustain in a heavy wind and all those things, the propellers, the motor can speed high or motor can speed run in a low mode. And next one, landing gear, as I discussed, how it is landed. With the 4 legs, with the 2 legs, and with straight line landing paths are also there. Certain designs are there. Which kind of landing gears are used for your road? And next one is our ground control stations, collections. What we can say, handheld device used manually to control the UAVs. Sometimes what happens, we can control the UAVs from a ground-based stations. Sometimes autonomous. We can program in a particular software. The autonomous UAVs are automatically taking that program. Now it can run automatically and capture the whole image. Okay. Now how the UAV is controlled on the basis of the ground control stations. And next one is about the safety and redundant systems. Now it is a very sensitive instrument. Whatever we are talking, it is giving good data and everything. And finally we are talking about the safety. Okay. It is a very sensitive instrument. While in the atmosphere, maybe high power towers are there. High power supply towers are there. Wires are there. Electric wires are there. Trees are there. If something which is hit, now the instrument is completely collapsed from a altitude of almost 1 kilometer, 500 meters, something. Once it is collapsed, what are the sensors you kept? What are the sensors here? Camera. Otherwise, LiDAR sensor. Otherwise, GPS module. And everything will be collapsed under the unable. Okay? These are about the various components of the UAV. Now, as per the classification, how we can classify the UAV data. Now, before that, I will tell you in the advantage manner how a UAV is much useful in terms of the land-based surveying techniques. Now, let us example, I want to do a survey for IIT Dhanbad area. Let us example we are talking 100 hectares. Okay. Now, first day we can go for the 5 people with 1 or 2 instruments. Okay. And we did around 3 to 4 acres of the land. As for the first day and second day data, we think that no, we require few more people. Area is bigger. We have to complete in a short span of time. We increase few people. And again, we increase a few more people. It means once the area is increasing, the manpower is increasing, the number of days are increasing to collect the data and for the planning and for the collecting the data and for finally processing the data and finally preparing the plan. If the area, survey area should be higher, let us examine the same case for the UAV. If the survey area is higher, पहले let us example EDC को सर्वे करना, then later on सर complete IIT को सर्वे करना, तो क्या होगा? In case of the UAV, number of flying hours are more. UAV में क्या होगा? Number of flying hours should be more instead of increasing the manpower. Here the flying hours more means we should increase the battery capacity of the battery. Otherwise, number of batteries are required. If you can draw a simple graph, that will be like, one is in terms of site area, in terms of the cost. So क्या होगा? It should be like this. The cost is increasing in case of land-based service, land-based acquisition. Now, in terms of the same land area, if you want to same land area which is increasing, we can do with the UAV. But if it is also increasing, but it will be like this. 25 acres से 30 acres हो गया. It means थोड़ा आधा घंटा और बढ़ाना पड़ेगा. 30 एकड़ से 70 एकड़ हो गया, बैटरी कैपेसिटी और थोड़ा 2-3 घंटा और फ्लाई करना पड़ेगा, एंड 30 एकड़ से 100 एकड़ हो गया, फ्लाई ओवर्स और 1 घंटा और बढ़ाना पड़ेगा। अदर देन द फ्लाई ओवर्स नंबर ऑफ इमेजेस आर मोर, इट मीन्स 1 घंटा से और 2-3 घंटा, here the time period and this one. But the same thing that is also happened in the land based survey also. But in the land based survey, number of working hours are more, number of worker people are more, number of instruments are more. Okay? While compared to the, if you compare the cost effective, okay? It is while compared to the land based acquisition, the drone is also a little bit of lesser cost for ground based survey. Okay? And now this is about the classification, how the drone is classified, what kind of drones are there, which way we can classify the drones. Generally we can classify the drones in terms of their altitude, on which height it is flying, and which range it is communicating, and next one, which kind of sensors which are attached to the drone, which kinds of payloads which are carried by the drones, and the kind of applications in the particular drone. Now this particular slide will give you about the UAV classification on the basis of altitude and range. Now let's see the altitude. If it is flying 0 to 100 feet, now those we are calling as a nano UAVs, very small. The next one is 100 to 500, micro UAVs. Now it is flying 500 to 1000 feet, we are calling as mini UAVs. Now 1000 to 5000 feet, it is all about the close range UAVs. And short range 5000 to 1500 feet, and 15,000 to 30,000 feet, that we are calling as a medium range, and 30,000 to 6,500 feet, that we are calling as a high altitude, especially in case of the missiles. In the last year we saw the Ukraine-Russia war. They use the high altitude UAVs for dropping the bombs and all those things. And these are, if you see, for nanos, the indoor surveillance and tight space reconnaissance. If you watch some of the videos, they are capturing the complete home tour. It is nano kind of UAV. It is flying around the whole area and it will capture a small video. Okay, very small nano kind of. Okay, it will record almost 15 to 20 minutes of video. Okay, it is just like an insect, honeybee. Okay, honeybee kind of. Now next one is micro, a short range surveillance, little bit of increasing the time and what you can say range. And next one, for agricultural monitoring point of view, a close range of and disaster assessment and medium range of surveillance up to 10 meters, up to 10 minutes, up to 20 minutes. We can surveillance the whole area. We can use such kind of close range UAVs. Now for the short range, for the military reconnaissance, in the terms of higher travel in the atmosphere. It means almost 20 minutes to 30 minutes, 30 minutes to 40 minutes. If you compare agricultural flying, how much area we can capture? At least 5 to 10 acres. But in case of military and all purposes, huge amount to be captured. Take for such cases, high capacity of traveling is required in the space. Now this medium, short range, and again the military long endurance surveillance, weather monitoring and communication release. It is all about the weather changes that will be happen for a longer period of time, not for a shorter period of time. For such kind of communications, these medium range UAVs are used. And again for the, as I said, in the high altitude, strategic military missions, global surveillance and satellite flight operations for a longer period of flying in the atmosphere, and high altitude pseudo satellites, HAPS, and these things which are, if you see the images, the first one that is about the black Harshad with almost 16 grams. That is, and next one RQ11, that is about 1.9 kg. And Predator, that is almost around 1000 kg. Now generally these are used especially in case of military purposes. Now if you see the civilians uses, those are about robot fly, it's almost all 1.5 gram. And next one crazy fly 2.2, that is around 25 grams. Next one is S1000, that is around 4 kg. If you what we can say, if you recollect the movie of Villuri, now in DRDO, one person is flying the drone in terms of the bird. That is also one kind of which is used for the military purposes. Okay. Now the classification on the basis of the altitude and the classification on the basis of the range, how much range it is communicated, okay, and how much time it is fly, and at what altitude it can fly. If it's a low altitude, low area it is covered, low surveillance. High altitude, high capacity is required for the flying, and high range of flying is required. Flight time is required. Now again, the classification again is on the basis of what we can say, kind of rotors. There will be 3 kinds of basic rotors are there. One is fixed wing, another is multi-rotor, and third one is about the hybrid. Here the multi-rotors, if you see the figure, the types which are calling as 3 rotors, multi-rotors are there, 4 multi-rotor propellers are there, 6 propellers are there, and 8 propellers are also there. This we are calling as propellers, as we discussed. Now what is the advantage of sir 3, 4, 6 and 8? As I connected in the earlier, if the payload increases, if power is also upliftment is power is also required. Upliftment power कैसे आएगा? Now we can use these propellers, ठीक है, to lift the payload. Why? Because there is only medium range of upliftment is there. Now with increasing these propellers from 4 to 6 and 6 to 8, we can uplift some limitation up to some quantity of payload. Okay? Now these are what is the description? Drones with multiple rotors like quadrupter, that is with a 4, and hexagon with a 6, and again we are having the 8, that is if you see this one. Why? Because the kind of sensors, the weightage of the sensors are increasing. Here the payload means you can think about the various kinds of sensors. LiDAR sensor is there, and again we are having RGB sensor, thermal sensor is there, hyperspectral sensor is there. Now other than this mapping, in the medicine point of view, we are carrying the medicines and all those things. Certain kinds of payloads are should be carried by these motors. Okay, this UAVs. Now to increase this what we can say, quad chopter, okay, the classification of the drone is also varies. Now the best for small to medium area of surveillance and detailed imaging and close range of service for a shorter area like IITISM, and a smaller area like 1 mile we have to cover. This quad or rotor kind of UAVs are useful, and the advantage is easy to deploy and operate. You can keep the UAV in the field and immediately you can fly it. And excellent for low altitude and high resolution mapping. And for a shorter region, it will give you a best resolution, high resolution, and it will go for the what we can say low altitude. In a small height also we can fly it. The next one is ideal for vertical mapping, especially in case of the urban and semi-urban region. Such kind of drones are using. What actually we are using, we are observed in the what we can say the society. The drones which are flied in marriage videos, drones which are generally what you are observed like flying in and around your buildings or in regions. Those we are almost all we are calling as a multi-rotor drones. And disadvantage is the battery capacity is very low. It can fly up to only 20, not only 40, it's fly up to 20 to 30 minutes also. Okay? And smaller coverage area per a flight. The smaller drone means only 20 meters, it will cover only such a smaller region. Again, change the battery, again fly it. Here, if it is fly 20 minutes means what? 10 minutes it is captured and again it is coming back. Okay? You have to calculate in that way. Okay? That's why it is telling very smaller region it is captured. Okay? And examples, these are the Phantom, DJI Phantom 4 RTK and Sensi Flight. Now, lot of the startup companies are also there developing their own drones in this particular region. Now, these are called, if you see, the multiple kind of rotors are attached. Battery. And next one is about the fixed wing. And the fixed wing aeroplane like drones with wings for gliding through the air, and best for large scale mapping, that is agricultural and forestry and natural disaster mapping and all those things, and mining. And the advantages are longer flight duration, that is around 1 to 3 hours, and coverage larger area in a single flight, and more efficient for a corridor mapping like roads and pipelines. But the disadvantages are requires a larger launching pad and landing space, more complex to operate. While compared to the earlier one, the multi-rotor and this fixed wing, what is the comparison? It covers the more area. It covers the less area. It requires no space for the landing and upliftment, but it requires for landing scale, take a landing path, and for flying and landing also, just like aircraft. Okay? And this is very less flight time. This is more almost 1 to 3 hours. This is around 20 to 40 minutes. It will capture larger area. It captures very less area. It will take less time for cover the larger area. It takes more time for the larger area. And again, especially in case of the drainages monitoring, pipeline monitoring, road network monitoring, railway monitoring, such kind of things, this fixed wing drones are used. Now for this purpose, only smaller areas like small agricultural mapping, smaller boundaries, smaller mining regions, such kind of this motor kind of. And each and every having their own advantages and their own disadvantages. And the third one is about combination of these two. This don't require any land for flight. This requires land for flight. If suppose I have both, now what is the advantage? Suppose I have the both. What is the disadvantages in the fixed wing? Disadvantages in the fixed wing is it requires a land space for landing. Take it. Now suppose if I kept some rotors, it can land at anywhere. Now the third classification is a combination of these two. It means both wings and rotors are. The advantage is cover the huge area, and also land wherever we require. Why? Because we are having the rotors. But the disadvantage is the maintenance cost is a little bit higher. You see the disadvantage, more expensive and mechanically complex, and requires advanced trainer to operate. I'll compare to those things. Advanced persons are required. He should having a proper mechanical instruments or mechanical devices are there. Now, operator who is expert in this particular handle such kind of thing, such kind of UAVs should be an expert. And next one, that is about fixed wing with the parachute drones. Now in the third one, what is the disadvantage? Disadvantage is mechanical complexity is there. Now especially for the military purpose, actually such kind of drones are designed. Once it is fly for a longer time,
Okay. Now, as for with the help of the parachute, it go for the landing. But the problem is inaccuracy in terms of the landing. And because it is depending upon the parachute, the landing is depending upon the parachute. Okay? Now, if you see the advantages of the long endurance and the safe landing in the confined areas, especially if suppose it is autonomous, we can use up to certain kind of programming. And the disadvantage is less precise in landing, requires post-processing for accurate maps. Whatever the data it is collected, and that should be, and the time of landing also, suppose it is captured the data. Now it is like inaccuracy data is coming. Now we have to proper processing is required process the data at the time of landing it is there. Now, 3 terms actually we should know before processing the data. Now, if you see the first one, this one, there will be 3 terms. Those are called row, yaw, and pitch. These are the 3 terms. If the UAV is flying in the atmosphere, there will be errors. Those are in terms of, let us example, this is the UAV. Okay? Now, why? Because in the atmosphere, not in our hand. Now, in the atmosphere, the errors at the time of capture. At the time of, now this is the vertical position. In this position, it should capture. Okay? Now, due to the bad weather conditions, otherwise atmospheric weather and all those things, maybe at the time of capture, it will be like forward direction or backward direction. इस position में exactly capture करना है. But at the time of capture, the flight will be move forward, otherwise the flight is move backward. That is one error. And another one is like this. Okay? Another one is like this. Now those 3 we are calling as a row, yaw, and pitch. If you see the row, that is on the basis of a linear. Okay? It is like this. Through the a linear area. Okay. Now let us example, this is the type. Example I am explaining with respect to this one. Let us example, this tile is one photograph. Okay. Next photograph should be captured. Okay. Now let us example, this is the first one. It is like this. वो टाइल एग्जैक्टली उसका प्लेस में नहीं बैठेगा, तो फोटोग्राफ कैसे आएगा? फोटोग्राफ ऐसे आएगा. ठीक है. Now such kind of error at the time of atmosphere, at the time of capture, we can't do anything. ठीक है. Now you should identify what is the error at that particular picture. What is the error in that particular picture at the time of post processing? Within the limit, we can correct it. ठीक है. Now again, one tile is like this. First one tile is like this. Okay, second tile is like this. तो दोनों एक साथ नहीं बैठेगा. एक टाइल ऐसे आएगा, एक टाइल ऐसे आएगा. थर्ड टाइल कैसे बैठेगा? थर्ड टाइल तो नीचे होगा ना. No, that is also another error. Now that error is due to the pitch. That is due to the elevator. And another one that is due to the rotor. ठीक है? Like this. ठीक है? One is like this. Another one is like this. Another one. ठीक है. There are 3 errors, which is one is aileron, another one is due to the rotor, and another one is due to the what we can say is elevator. ठीक है. At the time of, especially at the time of capture, we can't identify such kind of errors. Maybe those are very minor, but once we getting that, we got the data. Now we have to, why? Because finally we have to prepare the ortho mosaic of all the photographs. We have to combine all the photographs and faintly make a whole photograph of the whole area. Now at that time, this kind of practical problems are coming by making the ortho photograph. एक photograph ऐसे होगा, एक photograph ऐसे होगा. Actually, it should be like this. But in the real scenario, इसका बाद इसको photo रखेंगे, ये ऐसे आएगा. इसके बाद ये ऐसे आएगा. इसके बाद ये ऐसे आएगा. Now you have to identify such kind of errors at the time of post processing. Okay? Now you should know what kind of error it is. and these are about on the basis of the classification, on the basis of the next one that is called sensing, about optical, RGB cameras, multispectral cameras, hyperspectral cameras, radars, thermal infrared cameras, and SAR radar sensing sensors. On the basis of which kind of sensor in your attached in your UAV, that is also one of the classification on the basis of the UAV. Okay, now the concerned sensor, the application part is different. Clear? And if you go for the two types of principles, that is one is about photo based UAV data and another one is radar based UAV data. In the photo based UAV data, it is simply collect the photographs. In the earlier we seen the what we say RGB camera, na? It is simply collecting the photographs. Nothing else it is collected. Now you combine all the photographs. Now this is a single photograph. You combine all the photographs like this. आप इस फोटोग्राफ में देखिए थोड़ा एजेस दिख रहे हैं ना, ये थोड़ा ऊपर आ गया है, ऊपर आ गया है, ऊपर आ गया, थोड़ा नीचे आ गया. That is called alignment. अभी हम लोग what we discuss. ठीक है? Now this is a single photograph of this one, and after that in ortho mosaic finally it is like this. And here the multiple photographs which are, this is called a single photograph, and after combining a multiple photograph, this we are calling as a ortho mosaic. Now in the photo based UAV collection, the multiple photographs are captured, and finally we mosaic all the photographs, we are getting a ortho mosaic. From the ortho mosaic images, superimpose your surface plan, otherwise existing plan, you can digitize the various features. But in case of the radar, the problem what we are getting, the advantage what we are getting is it will scan the entire area into number of laser beams. Now each and every laser beam, a point cloud data is collected. Now here 1, 2, 3, 4, 5, 6, 7 like this 10,000 lasers are there, and 1,000 point clouds are collected at a time. And the earlier only photographs are collected. Here instead of the photographs 1,000 points are collected. If suppose 1,000 points x comma y comma z I know, now the complete topographical map is prepared. Okay? But how I get the x comma y comma z? You can enable a GNSS, a precise GNSS in the particular UAV. That GNSS will give you the x comma y comma z of each and every point. Now this final image which will give you a, this is the radar based image. You see these are, it is looks like an image, but it is not actually the image, it is a point data, multiple points. But the only the disadvantage of this radar data is huge amount of points are collected. It will collect huge amount of points. Okay. Now to sometimes to remove such points to enhance the radar image also. Okay. But in the earlier case only photographs, here number of points. Okay. Now let's go for the application part of the UAV. Now till now we discussed about the basics about what is UAV, what is the classification of the UAV, and what is on basis of the sensor, on basis of the payload, on basis of the flight time, and we discussed the various classifications, and again we discussed about the various components of the UAV, payload, what we can say, camera, angular, frame, and everything. Then we will go for the applications. I will give you a broad applications in terms of the environmental. I give you a broad applications in terms of the archaeological, in terms of the mining. Okay? Now first one, that is about land surveying. Now for especially for the topographical mapping, a high resolution satellite image is required. In terms of the UAV, you will get a high resolution of photograph. Upload. If you see this one, this is one of the best example for This is one of the best example for topographical mapping. Can I find the area? Can I find the area of this parcel? Okay. But for find out the area of this parcel, especially by using the land ground-based instrument, first of all you carry your tape here, tape measurement. Otherwise, with the total station, keep your prism here, prism here, prism here, prism here. Once while directly capturing this image, you simply draw a polygon. After georeferencing, you will get the area of that particular parcel. Now, this is one parcel. Now, let us example I given this image. How much time you will get to find the area of each and every parcel? Only simply digitization of the each and every polygon. Maybe it will take 1 day. Maybe it will take 1 week. If it is a larger area, maybe it will take 1 month or a little bit of larger area for a whole district. Now the revenue plan that can be updated by using this kind of UAV data in 1 month or 2 months or 3 months. Okay? That is one of the example in terms of the land-based surveys, that is called as a topographical mapping. And the boundaries. The municipalities nowadays they are approaching these UAVs to collect the boundary of each and every building for house tax. Now everybody is paying house tax, na? On the basis of your plinth area. Okay. Now how you got the plinth area? कोई सर्वे किया आपको बिल्डिंग को? सर्वे किया तो कब सर्वे किया है? There is a plinth area, na? You are paying tax on the basis of the plinth area. When that plinth area is defined, who done the survey? On which year the survey was done? As of your information. Maybe 20 years before, 15 years before. Now the municipalities are using these geomatics techniques to capture the building area by using a UAV. Can I find out the building area? Take it. Now on the basis of the area, can I collect the tax? Maybe it is higher, maybe it is lower, and everything. Take it. This is one of the application for the urban regions, how the UAV can be used. And the next one is about the topographical maps, the topo sheets which are prepared in 1970s. Now over the period of time, those are updated by using the satellite images and UAV data. Okay? And next one is about the agricultural. If you see the image, that is one of the thermal sensor image which will provide the leakage of the pipeline in agricultural land. आपको black color dots दिख रहा है ना? Have you seen the black color dots? That will give you the leakage of the pipeline. This example of one of the research paper in the US. They are identify the thermal sensor for that agricultural land, which extract the thermal image. From the thermal image, they are identifying the moisturized area. And they are concluded that yes, there is a leakage of pipeline in the particular area. The next one, that is about the construction and infrastructure management. Now, in the real estate, I am telling you, some of the sites, the owner of the particular real estate, owner of the particular, suppose I have a land in Lucknow. 1 acre of land is there. I want to construct a big mall. Now I deployed only few site engineers. Instead of the maximum number of people, I deployed only few site engineers, 7 to 8 site engineers, and every day I ask them send the drone image data in terms of the video or in terms of the photographs. Now my work is I am sitting in Dhanbad, I am monitoring the entire footage and what is going on in the particular site. The live cameras also. Take it with the live drone camera, live camera. Suppose around 2 o'clock there is a slab construction is going on. I fly the drone, how the slab construction is going on, up to what percentage is completed, take it, whether it is finished by which time. Such kind of live data is also we can use the drone. We can use the UAV data. and site planning and execution. Everything that will be used on the basis of the drone data. And next one, in terms of the environmental monitoring, if you see, this is one of the example. There is erosion of the sand. This erosion of the sand will create a problem for the ranking of the beaches. Okay, suppose there will be a beach in India which is heavy tourism is, but over the period of last 5 to 6 years, the people are died because the problems are, one is sand eroded, the water is moving forward, and while going to the backward, there will be a erosion of huge amount of soil. Due to that, the slope is increasing. Okay, people will be taken in the backward movement of the. Okay, now due to that also there will be, we are identifying number of cases in dying situations that impose the ranking of the beach for the tourist visit and everything. Now this is just like one of the example of how much percentage of the erosion is happening with the UAV data. Now if you see, this is the graph, and this will give you an example, the red color and the orange color and the yellow color, which gives you the range of erosion. The red color is higher erosion is there, orange is little bit of lesser, and the yellow color and lesser erosion that is happening with the UAV data. The next one is about the transportation. Now this is also one of the LiDAR image data which defines the road mapping of a particular university, otherwise particular town or urban region. The next one is about mining, the mapping of the mining region. If you see, this is about the various benches. These are the various benches. Now with the help of the UAV data, today how the benches are there, and tomorrow how the benches are there, what is the progress of the mining, how much ore it is extracted. Today morning I captured the whole area with the UAV, and again after 2 days again I captured the whole area. Now today how much ore is there, after 2 days how much ore is there. I said that we will get the point cloud data, x comma y comma z. Now z what is today, after 2 days what is the z. The difference of this one multiply, you will get a, multiply with the area, you will get the volume of the ore which is extracted. Okay? Now these are some of the figures which gives you an idea about how we can utilize the UAV. And next one is also about the disaster management. This will give you an example of, in case of disasters, how we can utilize, like especially in case of the earthquakes, in case of the flood monitorings, how we can fly the drone. And in the last year also, some of the floods have happened in a few states. They identified the people who are stuck in the floods. They fly the drone, okay, and they identify the people, which area the people are stuck, and the government take a decision whether they can rescue immediately. If not, they can supply some food packets, otherwise some needful things. Okay, and meanwhile they are making arrangements for rescue, all those things. Now in such cases, these UAV images, UAV data, which helps us, especially in case of such natural disasters. And next one is about the archaeological and cultural heritage. It is our responsibility to, what we can say, keep the archaeological things in a safe for future generations. Now such kind of UAV records, you capture the whole area and keep that record in a safe place. That helps us for the continuous monitorings. If you have the cases like this guard is having this much of gold, this guard is having this much of valuable things. How we know? They are making into a list. This is the value of the gold, and this is almost 100 kg. This is the diamond, almost all 5 kg. This is some of the silver, this much, in 1960. If they maintained on the record, then only we know in 2025 how much it is available in 1960. Now this UAV data, which especially helps us for the archaeological department, what is the present condition of that particular site? In 2025, something is happened, few local, they have done something. Now we are having a footage of 1990s or 2025. In 2050, we talk about, yes, this is the image, the site is looks like, something is happened there. Okay? Now, the archaeological department, they are using this kind of UAV drone images for the various capturing in terms of the photographs and videos. And again the solar also, for the solar, sir, what is the requirement of the UAV? Now, especially in case of the maintenance, you can clean the solar from grabbing the maximum power. The panel should be clean, neat and clean. Now once we fly, for a smaller area, it is okay, visually we can do that. For a larger areas, what happened? We have to monitor all the solar panels. Now once we fly the drone, visually we can say that which area it is dirty, how much area we can clean in a day, in a month, we can plan accordingly with this footage. And in the scientific researches nowadays, what happened? Like if you see the figure and adapt to the one of the example of Kumbh Mela. The Kumbh Mela is, they are taking continuously the various footages, they are flying the drone and they are taking the various footages. That footages are directly sent to the control room. From the control room, they are taking decisions, which area it is okay, which area could be hazard. Why? Because once the movement of the population is captured, that will give an instruction to the concerned team in the next coming 15 minutes, next coming 20, what we can say, 20 minutes or half an hour, these many people are visited to this particular site. In one of the example, the CCTV cameras are, on the CCTV cameras, they are taking a decision which gate to be opened, which gate to be not opened, which way we can divert the pilgrims. Why? Because sometimes what happens, huge population will be crowded in one gate. Now with this monitoring, with this UAV data, we can take a decision that this is overcrowded, we can divert the people to some other gate or some other direction. Okay? These are some of the examples, especially for the environmental monitoring and geological conditions. Hyperspectral data can be used for the geological studies in terms of the UAV. And these are some of the examples of a affected electrical wires. If you see this one, have you seen this yellow color line? बहुत छोटा है, yellow color line दिख रहा है आपको? This line is affected with the thermal cameras. Okay. Now the power supply department also acquire these UAVs. Okay, to identify the which line is oversupplied, overpowered, and which line is damaged, which line is not giving the power, and all such things are also the applications of this UAV in electrical controls. In one of the reel, I observed that the nest of, that is cleared by these drones, small drone, quad multi-rotor drone, which is flight. And they have removed that nest in the between two wires. Okay, why? Because man cannot approach that particular place. Now drone is deployed and it is completely removed. Again, there is huge amount of comments are coming. Why the municipality people have removed such things and all those things? Immediately on the next day, they deploy one more new nest nearer to the electrical. It means that the thing is we can use such kind of, why? Because there will be two things should be in mind. One is about UAV should be used for the surveillance, UAV should be used for surveying. For the surveillance, much accuracy is not required. For the surveying and mapping, high accuracy is required. On which way you are using the UAV. if you observe the use of UAV, especially in case of the birthday parties and marriages, it is coming to zoom like it is coming back. For this, though no accuracy is required. Whenever they can fly, they can drop. नीचे तक आएगा, ऊपर तक चला जाएगा, ठीक है? वो बाहर में ज़ूज़ करके आएगा, then again it will go up, again it will go down. There is no much accuracy is required. But you can use the same drone for a surveying. You have to maintain the proper altitude. You have to maintain a proper speed. ठीक है? In a certain flight path, these many images to be captured. You have to keep the overlapping area and side lap area and all those things. Now, by using the drone, you have to keep it in mind for what purpose you are using. For surveying purpose or for surveillance purpose, you are using. Clear? Okay? Understand any doubts? Is there any doubts? No? Okay. Thank you.